So next up is the Sn1 mechanism. Now the Sn1 reaction happens in 2 steps via a carbocation intermediate. Remember that this carbocation is subject to rearrangement, which means you may get multiple products if you're doing the Sn1 reaction. Now I'm going to show each individual step here. So we start first in the Sn1 reaction with the departure of the leaving group. You'll notice that I'm using a double-headed arrow because this is a 2-electron process. I'll also identify this iodide here as the leaving group because it's a halide and therefore it's stable by itself. This generates the intermediate here. Now I want to draw your attention to an important feature of this intermediate. This is a carbocation and it's sp2 hybridized, which means it's flat. Now this is important to us because the nucleophile can attack from above or below. And this will be important when we think about the stereochemical outcome of these reactions. So I can attack from above or below using my nucleophile. Now the nucleophile here is going to be the sulfur atom, and it's the nucleophile because it has 2 lone pairs. I'm just going to show one set to keep it simple, and this can attack my electrophile like so. Now that gets me to this product here, where this product has a new electrophile nucleophile bond. The last thing I need to do is I need to abstract this hydrogen atom in order to get to my final product here, which is neutral. This would be done using some sort of base. Here I'll show the base coming in, abstracting this hydrogen atom to send 2 electrons up to the sulfur to get that final neutral product. So we have the leaving group, which was the iodide. We have the electrophile, which was this carbocation intermediate here, and we have the nucleophile, which was the sulfur. Now remember that an intermediate is something that is formed en route that is spectroscopically observable. In other words, it lives long enough for us to get a look at it using spectroscopy. That also means that it is subject to rearrangement. So watch out for rearrangement as that'll lead to the formation of multiple products. If you make a chiral product in the Sn1 reaction, you will get a racemic mixture, where that racemic mixture is at 50-50 distribution of enantiomers. Sn1 reactions will give 2 products when things are chiral. And this will be important for us to contrast to the Sn2 in just a moment. So to recap, the Sn1 reaction has departure of the leaving group to make a carbocation, which could be subject to rearrangement. That carbocation is then attacked by a nucleophile, which may or may not need deprotonated to generate a final neutral product. In that attack of the carbocation, if I am to make a chiral product, I need to draw both, which would be formed in a 50-50 distribution. The carbocation is sp2 hybridized and flat, which means it can be attacked from above or below with equal preference, which is what leads to that 50-50 distribution of chiral products.